TechnicalCalc.com. We're doing a Euler's method problem today. The problem that we're given is actually phrased as an initial value problem. They asked us to consider the initial value problem dm over dt equals 0.07 m minus 14,000. So they say consider this initial value problem with this function and with m of 0 equal to 120,000. And then they ask use Euler's method with delta t equal to 1 to estimate m of 5. So we're given this problem. It's an initial value problem because we have this function and then the initial condition, but we're asked to use Euler's method to estimate m of 5. So essentially it's a Euler's method problem. And when we have a Euler's method problem, the first thing that we want to do is make a chart. So we're going to have always t of 0 in the first row, and then m of 0, in the first column, and then m of 0 in the second column. We have t and m because we're given t and m in our problem here. So whatever's on the bottom goes in the first column, whatever's on the top goes in the second column. And t of 0 and m of 0, you always start with zeros. They come from the initial condition. So t is this number here because it's m of t, right? And then m is this number when we're given an initial condition like that. So we say t is 0 and m is 120,000. Okay, so that's our first row of our table. And then we need to start building the table. So the first thing we do, we want to build out this t column. And the way that we do that, they gave us that delta t, or the change in t, should be equal to 1, and that they want us to estimate m of 5, or in other words, when t equals 5. So we will say t1 equals, right? They want the change in t to be 1, so that means we're adding 1 every time to whatever we started with. So 0 plus 1 would be 1. 1 plus 1 would be 2. 2 plus 1 would be 3, right? So you get the idea. And we want to estimate m of 5, so we need to keep going until this equals 5. Obviously, in this case, that's really simple. And there we go. We got to 5. So that's our whole t column because this is m of t, so when t equals 5, we've got t equal to 5 here. So we want to estimate whatever m is in this row here. And of course, now that we've done that, we'll have to start building out the m column. And the way that we do that, the Euler's method formula is the following. The formula in the couple books that I have is like a big table and kind of complicated, but really the only one you need to remember is the one immediately following m0, which would be m1, because you're given m0 in the initial condition, and the formula always stays the same afterwards, but that first step is the one that you need to remember. So the only thing I remember is the following, and we'll go ahead and use m's. In my formula, it's y's and t's instead of m's and t's, but we'll go ahead and use m, so it's not as confusing. So we have m1 equals m0 plus f of t0 m0 times, that works, times delta t. This is our whole formula here. So we have that formula, and I always use m1 because that's the first one that you need to remember. Everything else is the same after that. So M1, we can see we have M0, so which was defined here, so 120,000 plus, and then this F of T0, M0 basically means what do we get when we plug in this value of T and this value of M to the original function. So as you can see in our original function here, we don't have any, we don't have T as a variable in this function, so we don't really even have to plug in T. All we have to do is plug in M. So let's go ahead and do that. We're going to plug in 120,000 because you can see we're plugging in T0 and M0. So for M1, we're always plugging in T0 and M0. So we plug in 120,000. So 120, times 0.07 minus 14,000. So it's negative 5,600. So that is going to be negative 5,600. And then times delta t, and delta t was defined as 1, so we just multiply by 1, which is really unnecessary. So then we have 120,000 minus 5,600 is 125,000, or sorry, it's actually going to be, sorry, I had a negative in there, so 120, so it's going to be 114,400 for M1. So then M2, and you'll start to see the pattern really quickly. And we can change our formula up here if we wanted as a guide. We just add 1 to every single one of these little subscripts here. So it was M1, now it's M2. This was M0, now it's M1. This was T0 and M0, now it's T1 and M1. See how we just added 1 each time? So M2 now is going to be M1, which we already got, 114,400, plus whatever we get when we plug in T1 and M1 to our original function.